Hello, 6th grade. This is your Module 5 review. All right, question 1. Jack is a groundskeeper at Triangle Park. The scale is shown below. So this is what the park looks like. Oh, that's supposed to say Jack. Jack needs to cut the grass 4 times per month. How many square yards will he cut altogether each month? So essentially we need to find the area of this section and then multiply it times 4. So the area of a triangle is base times height divided by 2, or base times height times 1/2. Both of those will get you the exact same answer. All right, so if we have the area equals base times height divided by 2, our base is 300 times 50 divided by 2. And I can grab my calculator for that. 300 times 50 is 15,000 divided by 2 is 7,500. Okay, so that is yards squared. Then, because we're cutting it 4 times per month, we're going to do 7,500 times 4 equals 30,000 yards squared. All right, during the winter, the triangular park and adjacent park lot are flooded with water and allowed to freeze so that people can go ice skating. What is the area of the ice? Okay, so we have this section right here. So again, we're going to find the area. So we have 50 times 50, or 50 squared, equals 2,500 yards squared of ice. All right, question number 2. Maria is looking for a new computer table. Below is a sketch of the 2 computer tables she likes when looking at them from above. All measurements are in feet. So even though we don't have labels on this, these are going to be in 1-foot increments. If Maria needs to choose the one with the greater area, which one should she choose? Justify your answer with evidence using coordinates to determine the side lengths. Okay, so here I have a space. So this is 5'3", 5'5", 12'5", 12'10", 5'10", 5'8". Okay, so actually I'm going to skip that because we didn't actually learn that. Essentially you learned, but that does take you into how to do this. So essentially you find the distance of the points. So here we have a distance of 7 between these points. This is 2, 2, 1, 2, 3, 1, 2, 3, 4. And then this is going to be, I think I measured wrong. 1, 2, 3, 4, 5, 6, 7. So then there's, if you remember, there's 2 ways to find the area. So we can either break this up and find the different areas, or we can find the area of the whole piece and then subtract. So if I'm looking at table B, so I can either break it up into these sections. So I'm going to have 3 sections. So I'm going to have 3 times 7, and then 1, 2, 3, 4 times 2, and I have 2 of those. Or I can do the 7 times 7, and then I have a 3 times 4 inside. So this would be 21, 8, and 8. If I add all those up together, I've got 16, 17, 37. And then here I would have 49 minus 12, which also equals 37. So 37 feet squared. So I do get the same answer because it's the same area. Here we can do the same thing. So I would break this up here. So we'll measure, we've got 1, 2, 3, 4 times 1, 2, 3 plus 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 9. So this I have as 12 and 27, which gives me 19 or 9, 39. Or the other option would be to figure out this whole section. So I'm going to do 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5, 6, 7, 8, 9, which equals 63. And then I'm going to subtract this section right here. So I've got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, which is 24. So when I subtract those, I get 13, 5, this is 9, 39. So I get 39 feet squared for both. So we need to figure out which one has a larger area. So now we're going to compare. So table A has 39 feet squared, table B has 37. So table A is larger because it has a larger area. Okay, so then B says she needs to choose the one with the greater perimeter. Which one will we choose? So perimeter, if you remember, is just adding up all the sides. So with table A, I've got 1, 2, 3, 4. This is 9, this was 7, this is 3, 1, 2, 3, 4, 6, and 3. So I'm going to add 3, 9, 7, 3, 4, 6, and 3. Oh, did I count that one twice? Counted that one twice. And then for table B, I have so I have 7, 7, 7, 2, 4, 3, 4, and 2. I'm just going to grab a calculator to expedite. 3 plus 9 plus 7. So this is 32 feet for table A. And then I've got plus 6 plus 7 plus 2 is 36 feet. So again, we're going to compare these. So table B has a larger perimeter. All right, so here we're finding the area of the triangular region. So we're looking for this right here. So again, the area of a triangle is base times height divided by 2. So we have our base here, which is 5. And then we need to figure out the height. So to figure out the height, we have to kind of do a little bit of interpretation of the graph. So this whole section right here is 13. This section right here is 6. So the remaining section then is 7. So I'm going to do 5 times 7 divided by 2, which is 35 divided by 2, which is 17.5. Just double checking. Equals 17.5, and we have inches squared. All right. Number 4. The grid below shows a bird's eye view of a middle school. So write the coordinates of each point on the table. Okay, so A, we have 1, 2, 3, 4. I've got -4. 1, 2, 3, 4. B then is, I'm going to put these on here too. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. C then is going to be a 6 again. And 1, 2, 3, 4, 5, 6, and a negative 6. D is going to be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 4, negative 6. E then is 4, negative 2. F is going to be a negative 1, negative 2. G is a negative 1. 1, 2, 3, 4, 5, 6, 7, negative 7. And then H over here is 1, 2, 3, 4, negative 4. 1, 2, 3, 4, 5, 6, 7. Okay, and then we can go ahead and put those in the into our chart. So C is 6, negative 6. D is 4, negative 6. E is 4, negative 2. F is negative 1, negative 2. G is negative 1, negative 7. And H is negative 4, negative 7. Okay, so then we're finding the length of the segments between these. So between A and B, it should be roughly 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From B to C, we should have another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C to D is 2. D to E, 1, 2, 3, 4. E to F, 1, 2, 3, 4, 5. Hold on. 1, 2, 3, 4. Yep, okay. F to G, 1, 2, 3, 4, 5. G to H is 3. And H to A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did I count something weird? 1, 2, 3, 4, 5, 6, 7. Oh, no, I see it. Okay. All right, so essentially these are just the distances, and you can figure those out based on the coordinates, but we didn't go over that too much. Okay, so this is the coordinates. See. Each space on the grid represents 10 meters. Find the length of each wall of the school. So all we're doing is we're multiplying these values times 10 then. So AB is 10 times 10, or 100 meters. BC is 10 times 10, or 100 meters. CD is 2 times 10, or 20 meters. DE is 4 times 10, or 40 meters. EF is 5 times 10, or 50 meters. FG is 5 times 10, or 50 meters. GH is 3 times 10, or 30 meters. And HA is 11 times 10, or 110. Okay, find the area of the entire school showing all your work. So again, you can break this up, or you can find the entire area and then remove these pieces. So whatever way makes sense in your brain, I can show both. All right, so I'm going to break break it up a little bit differently this time. Okay, so I'm going to do this way and this way. And I'm just going to label these 1, 2, 3. All right, so section 1 then is 11 times 3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, which is 33. Section 2 then is 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, 6, which is 30. And then section 3 is 2 times 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is 20. If I add all those up, I've got 83 meters squared. Or if we're going to do the whole section, so I have 11 times 10, which is 110. And then I'm going to subtract out, so if you notice, there's a little section here that doesn't match. So I'm going to do a 2 times 1. And then I'm going to do this section here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I have 110, oops, sorry, minus 2 minus 25. Grab our calculator real quick. 110 minus 2 minus 25 gives us 83 again. 83 meters squared. So again, I'm getting the same answer because it's the same area. I'm just doing it 2 different ways. This is adding up the areas. This is taking the whole and then subtracting. Either way is completely fine. You learned both ways. It just depends on which way you prefer. All right, the juice box pictured below is 4 inches high, 3 inches long, and 2 inches wide. Okay, so this section right here is 4 inches. This section here is 3 inches, and this section here is 2 inches. In the grid above, the distance between grid lines represents 1 inch. Use the grid paper to sketch the net of the juice box. So if you remember when we did the nets, you had to kind of pop it open somehow. So you're going to have 2 kind of longer ones, 2 smaller ones, and then 2 somehow on the side. So because you can open this up anyway, yours is going to look slightly different perhaps than mine. But I'm going to do this 3 times 4 first. So 1, 2, 3, and then down 4. 1, 2, 3, 4. So that is this piece. And then I'm going to do a 2 times 4. That's the side. Then I'm going to come back and do the back. Oh, sorry, that needs to come down one more. And then the side again. And then we're going to do this top and the bottom. So again, it doesn't matter where you have it. So I'm going to have a 2 times a 3. And you can label it too. So this would be the front, left, back, right, and then I'm going to say this is the top and this is the bottom. It does not have to look like that. As you remember, a lot of the nets that we worked with, they looked different, and then they all folded up to the same. Okay. Find the surface area of the juice box showing your work. So we're finding all of these pieces. So we have 3 times the 2, which is the bottom, and we have 2 of those. Then we have the 2 times the 4, and we have 2 of those, and then we have the 3 times the 4, and we have 2 of those. So 2 times the 3 is our top. 2 times 4 is our side, and 3 times 4 is the front and back. So this becomes 2 times 6, 2 times 8, and 2 times 12, which is equal to 12, 16, and 24. So 10, 12, 2, 3, 4, 5. So we have 52 inches squared when we add all of those up. Okay, then the volume, we're just multiplying all of those together. So we have 3 times 2 times 4, which simplifies to 24 inches cubed. All right. The Cubic Crystal Company has a new crystal cube they want to sell. The packaging manager insists that the cubes be arranged to form a rectangular prism, and that the package must be designed to hold the crystal cubes exactly with no leftover packaging. So they don't want the cubes, the boxes, to shift at all and break. Each crystal cube measures 1 inch by 1 inch by 1 inch. There are 24 crystal cubes to be sold in a box. What are the dimensions of the possible box design? So if we're finding the volume of these individual cubes, 1 times 1 is 1. Okay, so the cube itself is 1 inch cubed, and we need to get 24 in there. So we need to figure out some ways to make a combination of 24 with volume. So we can start with the 2 times the 3 times the 4 that we did. So 2 times 3 times 4. So 2 times 3 is 6, times 6 is 24. So that'll give us 24. We can do 1, let's see, 2 and 6. 6 times 2, no. We're going to make that 2. 2 times 6 is 12, times 2 is 24. I have 1 times 2 times 12. There's a lot of different combinations. These are just some that you can use. All right, which crystal box design will use the least amount of cardboard packaging? Justify your answer as completely as you can. Okay, so these are all going to give me a volume of 24, but based on this, based on these options, based on your options, you're going to figure out the surface area of that. So if I'm using these same values, I need to figure out the surface area. So the surface area then is going to be, and you can draw this out a little bit. So my height for the first one would be 2, my width would be 3, and my length would be 4. So I would have a 4 times 2, and I'm going to have 2 of those. A 3 times 2, and I have 2 of those. And then, which one am I missing? And then a 4 times 3, and then I have 2 of those. So I'm going to have 8. 4 times 2 is 8. Times 2 is 16. So I'm going to have 16 plus 3 times 2 is 6. Times 2 is 12. 4 times 3 is 12. Times 2 is 24. So this one gives me a total of 16 plus 12 plus 24 is equal to 52 inches squared. Okay, let's do the rest of them then. So I'm going to do the same thing. So I have a 2, and a 6. So to figure out the sides, I'm going to do 2 times 2. And then I have 2 of those again. So I have a left and a right. This side piece is 6 times 2, and I have 2 of those. And then the bottom is also a 6 times 2. And I have 2 of those. So I have 2 times 2, which is 4, times 2 is 8. 6 times 2 is 12, times 2 is 24. 6 times 2 is 12, plus 24. So that gives me 48 plus 8 is 56 inches squared. And let's try this last one. So again, you can kind of draw the box out and see, put your labels in to help you figure out what you're doing. So I'm going to do 1 here, 2 here, and 12 here. So this bottom piece is a 12 times 2. And then I've got 2 of those because I've got the top and the bottom. This side length is 2 times 1. And I've got 2 of those. And then I have to do this piece right here, which is a 12 by 1. And I've got 2 of those. So 12 times 2 is 24, plus times 2 is 48, plus, so I have 2 times 1 is 2, times 2 is 4, and then 12 times 1 is 12, times 2 is 24. So that gives me a total area of 48 plus 4 plus 24, which is equal to 76 inches squared. So the best way to do it would be the 2 times 3 times 4 because it uses the least amount of surface area or the least amount of cardboard. Okay. Another type of mini cube is the mini crystal cube, which has an edge length of 3/4 inch. What is the volume in cubic inches of 1 mini crystal cube? Show your work. So if I have my cube, since all sides are the same, this is going to be 3/4, this is 3/4, and this is 3/4. So I have 3/4 times 3/4 times 3/4. 3 times 3 is 9. Times 3 is 27. 4 times 4 is 16. 16 times 4, I think 4 times 16 is 64. So it's 27/64 inches cubed. All right, last page then. All right, so we want to know which of these nets can be folded to form a cube. So here I've got 1, 2, 3, 4, 5, 6. I've got 6 pieces, but when I fold them up, I'm missing a side and I've got 2 tops, so that doesn't work. All right, let's check this one. 1, 2, 3, 4, 5, 6. I've got 6 pieces again. Okay, so if I fold these up together, I'm going to have 3 sides. But again, it's going to fold over, so that's not an option. And then here I've got these sides, so D is our answer. All right, then here, last question, which box below has the larger surface area? So you're doing the exact same thing. So I have, this is 10 by 3, this is 3 by 1, and then this is 10 by 1. Okay, and because I've got this top and this bottom, this front and back, and these 2 sides, I have to multiply each of those times 2. So I have 2 times a 10 times 1, plus 2 times 10 times 3, plus 2 times 3 times 1. Okay, so 10 times 1 is 10, times 2 is 20, 10 times 3 is 60, times 2 is 120, 3 times 1 is 3, times 2 is 6. This simplifies to 146 inches, cubed. Okay, then let's try this one right here. So this right here is a 5 times 3, because you have the 5 length, 3 is a height. This is 2 times 3, and then this is 5 times 2. Okay, and we're going to multiply each of those times 2 as well. So I have 2 times the 5 times 3, plus 2, 5 by 2, plus 2, 2 by 3. 5 times 3 is 15, times 2 is 30. 5 times 2 is 10, times 2 is 20. 2 times 3 is 6, plus 2 is 12. So 30, 50, 62 inches squared. Okay, so this box has a larger surface area. Okay. All right, that is the end of the review. Let me know what questions you have over the weekend, and your test will be on Monday. Good luck.